Okay, so we're picking up on objective 5.7. This is going to be part B, solving exponential equations that are at more advanced level. And you'll be successful when you can solve exponential equations that require multiple strategies or multiple types of properties to get to the answer. Okay, so let's start with example 1, which has 2 problems for us to review. So anytime I come to an exponential equation like this, which I know is an exponential equation because the exponents are unknown. That's what makes it an exponential equation. The first question I ask myself is, can I keep it simple? Can I avoid using logarithms to solve this equation? And so I look to my base numbers, 3 and 27, and I think, can I make them into the same base? Yes, you answered my question. I can write 27 as a base 3 because 27 can be replaced with 3 cubed, right? So we have on the left 3 to the x squared plus 2x power equals 3 cubed. And then I will just remind you of that exponent property that we learned about back in the day a while ago, that when we have some base number raised to some power, and on the other side of the equation we have that same base number raised to some other power, if my bases are equal, then my exponents are equivalent. They have to be. And so I'm going to be using that property right there, that exponent rule, to solve this equation. If my bases are the same, then my exponents must be equivalent to each other. So I can just drop the bases and solve the exponents. Since it's quadratic, I'm going to have to use my quadratic formula or my factoring skills and find my zeros. So we're going to subtract 3 and move it to the left. Take it over. And this is easily factorable, so let's not go to the quadratic formula. We'll open up our binomial pairs, break up our x squared into x times x, and stop and think. I'm looking for 2 numbers that multiply to -3 and add to 2. -1 and +3 would work great. So I have factored those down, so now my x's are to the first power. And so either this has to equal 0 or this has to equal 0 if I'm multiplying them and they equal 0. So we would say either x minus 1 equals 0 or x plus 3 equals 0. Therefore, x must be either 1 or x is -3. And then, of course, we're going to check our solutions to make sure that they are both correct and not extraneous. So we'll be plugging these values in. So my first check, I'll do 3. Replace the x with a 1. Squared plus 2 times 1 equals 27. And we don't need a calculator for this. That's 3. And that's 1 plus 2. So 3 cubed equals 27. That's true. So we know that 1 is a good solution. And we'll go back and check by plugging in the -3 for our x. So 3 raised to the -3 squared plus 2 times -3 equals 27. And -3 squared is 9, and 2 times -3 is -6, and 9 minus 6 is 3, and 3 squared equals 27. Therefore, -3 is also a good solution. So no logs necessary, no calculator necessary to get us to our solutions. Hopefully you remember that now. It's kind of refreshed your memory. It's your second time going through these types of problems, so this time you'll probably be faster, a little more confident. Let's try the next one. Here we have another problem that is similar. And so again, I ask myself the equation, can I avoid converting to logarithms to solve this equation? So I ask you, can I make 136 base 6? Yes, because you know 136 is the same as 1 over 6 squared, and if I want to move that to a base 6, I had to push it to the numerator, it's a negative 2 exponent. God bless you. So we know that 6 to the x squared minus 3x is equal to 6 to the negative 2, common base. Since my bases are equivalent, then my bases are equal. So my exponents are equivalent. And then you go through that same process. I'm going to let you solve that. And then we'll come back and see if you've got it right. So go ahead. So if you tried that out, you should have got the answers 1 and 2. And then when you plugged in the 2, you got a true statement. When you plugged in the 1, you got a true statement. So they're both good answers. All right. So now we're moving on to the beast, which is this problem right here. I'm going to tell you right now, write yourself this off to the corner. This is going to require you to use a combination of exponent rules and log properties. We've got to do a little work on this problem in its exponential form before we can transfer it into log form so that we can solve it. So I'm going to remind you of an exponent rule that will be really helpful here. So I'm going to put this over in your left hand column over here. And that's the rule for exponents that says, and I'm focusing on this first section right here. If I have some base raised to some power plus another power, I can use my exponent rule that says that I can separate them. And I want to separate the exponents because I'd like to pull, in this situation, the x away from the 2. So I can rewrite this as b to the x times b to the y. Okay, we typically write them in reverse order, right? For example, if I say I want you to multiply x squared times x cubed, you know that what you're doing in your mind is doing x to the 2 plus 3. X to the 5th, correct? So what we will be doing is we will just be working this idea in reverse or conversely. So what I'm going to do here is apply that right here. So I'm going to replace 3 to these 2 separate exponents into 3 to the x times 3 squared. They say the same thing. They're equivalent to each other, but that does help me to separate the 2 from the x. Minus 3 to the x equals 16. And actually, I should have said, the first thing I ask myself is, can I make them all base 3? And the answer is no, I can't write 16 as a base 3. So I am trying to simplify this so that I can solve it, because at some point I'm going to need the logs to solve it. So I can get these exponents down out of their position. So does anybody see that I could actually just go ahead and factor that common factor out of those 2 terms? Do you see it? I can factor out 3 to the x. And if I take the 3 to the x out, that leaves me with a 3 squared minus 1 equals 16. And I'm feeling a little bit better about my chances for solving this problem. That's a 1, by the way, not a 7. So now I'm going to work this because I can. So that's 3 to the x times, you agree that's 8, 9 minus 1 equals 16. And then I really would like to get that x isolated as much as possible, so shall I divide by 8? So that would give me 3 to the x equals 2, because we're dividing by 8 on both sides. Cancel that out. Now, I've got it into a form. These two things, by the way, are equivalent. That big long statement at the top is exactly the same as the statement down here in simpler form. But now I can apply that rule that says if x equals y, then the log of x equals the log of y, which is property 8, which is what we practiced yesterday a lot, right? So I'm going to go ahead and use the natural log if you're okay with that, because I'm feeling a little bit lazy. So the natural log of 3 to the x power equals the natural log of 2. Still the same statement, just converting it to a log so that I can power down using property 7. So that's x times the natural log of 3 equals the natural log of 2. Now that that x is down out of its lofty position, I can go ahead and move the natural log of 3 to the other side of the equation. So x is equal to the natural log of 2 divided by the natural log of 3. We'll plug that into our calculator and we will get x is equal to approximately 0.6309. And then, of course, after all that work, we want to make sure that we've done everything properly, so we will check it by plugging this value in to the original equation. So when we plug 3 to the 0.6309 plus 2 minus 3 to the 0.6309, guess what we get? Exactly 16. And I mean exactly 16. And so therefore, we can now say for sure that our solution is correct. We'll write it in solution set. Okay, do you have any questions? Okay, so we're going to move on to our last example. Here's example 3. And the only thing I would warn you against is this. I need you to know that 3 times 2 to the x power is not 6 to the x power. It is not. It is not. So don't try to combine them. Okay? Instead, what we're going to do to solve this exponential equation is we are going to use 2 different log properties. And so we're going to be using log property 5 that says when I have the log of a product of A times B, it's condensed. I can expand it and separate log A from log B through what operation? Addition. Okay, so I will be using that property along with property 8 that says if some number m equals some number n, then the log base of m equals the log of n. Okay, so I will be using both of those. The first one I will use is 8 because this is a condensed log and this is a condensed log. As soon as I drop in the log. So if these numbers are equal, then their logs are also equal. And I'm going to change that notation to a times sign like that. Equals the natural log of 5 to the 3x. Then I am going to expand because this log of 3 doesn't contain an x. I want to keep it separated from these logs that do contain an x. So I'm going to use log property 5 that says the log of a product is the same as the sum of the logs. Okay, so I used property 8, then I used property 5. Now I'm going to use property 7 that says power down. If I want to solve for x, I have to get the x's out of their exponential positions. So that's the natural log of 3 plus x times the natural log of 2 equals 3x times the natural log of 5. I'm going to move these little numbers that I'm writing down over here away. And so it's feeling a little better now that my x's aren't up in the exponent. But I do need them on the same side of the equation if I want to solve for x. So I would say that I'm subtracting this term and moving it over here. So natural log of 3 is equal to 3x times the natural log of 5 minus x times the natural log of 2. And that again is I'm just subtracting so that my x terms are on the same side of the equation. And then I think, can I combine these two terms? Are they like logs? No, that's a log of 5 and that's a log of 2. I can't combine them. So that means to get my x's together, I have to factor it out. It's a factor. 3 times x times natural log of 5 minus x times natural log of 2. So I can factor out the x, just like so. So x times 3 times the natural log of 5 minus the natural log of 2 equals the natural log of 3. And I've finally separated my x from everything else. Now I just need to move this everything else to the other side of the equation through division, correct? So if you don't mind, I'm going to write it switching sides. Natural log of 3 divided by 3 times the natural log of 5 minus the natural log of 2. Then we'll plug that into the calculator and we get the answer 0.2657. And then, of course, because we're careful, we check it. And we just plug it in exactly how it's written. So 3 times 2 to the 0.2657 should be equal to 5 times 2 to the 3 times 0.2657 power. And when you plug that into your calculator, you get the answer, 3.6066 equals 3.6066. True statement. Just plug it in your calculator, it'll spit those numbers out for you. Therefore, my solution, that is not what I wanted to do. Let me try that again. 0.2657 or 2,657 10,000ths. But who wants to say that? Okay, again, your homework tonight is 17 through 24. If you want to try 25 through 28 extra credit, 4 points apiece for getting through them. These problems are 2 points apiece.